Hi guys, welcome back. We're going to have a quick look at the factor remainder theorem. So using long division, we were able to determine the quotient when we were dividing through by a polynomial. So if you go back and have a look at that last video on long division, you'll know what I'm talking about. But basically, if I have a function, so f of x, and I divide that by a linear factor, so by linear factor, I just mean that the highest power inside the bracket is going to be x to the power of 1. So if I divide that by a linear factor, then I should get a remainder of 0, okay? Because if it's a factor, it's not going to have any leftovers. It's like saying 3 is a factor of 6, because 6 divided by 3 is 2, with 0 left over. So the remainder is going to be 0. So that's what we're going to focus on. The remainder has to be equal to 0. Now the factor remainder theorem is actually really nice, because if x minus a is a factor, so in other words it has a remainder of 0, then what I can do is I can substitute a into my function and I should get a value of 0. So let's try using this first example here. So if I did x cubed minus 3x squared minus 6x plus 8 equals y, just for a second, we're going to ignore that equals 0 for a bit. So what we're going to do is, first things first, I'm going to choose some values of a to substitute in here to see if that's going to work. And I'm going to do that by actually choosing the factors of d, and they're going to inform me as to whether or not they are factors. So if I look at the factors of 8, I could have 1 or 8, or I could have 2 or 4. So I could have something like x minus 1, or I could have x plus 1, or I could have x minus 8, or I could have x plus 8. So I would have to go through and I would have to test all of these to see which one of these values is going to be equal to 0. So let's try the first one. Let's do f of x divided by, let's just do x minus 1. So that should have a remainder of 0, and I can test that by substituting in 1 into that equation. So I'm going to get 1 cubed minus 3x squared, that should be minus 1 squared, minus 6 lots of 1 plus 8. Okay, so this should equal 0. We're hoping that's going to be equal to 0. All right, so 1 minus 3 is going to be negative 2. Negative 2 minus 6 is negative 8. Negative 8 plus 8 makes 0. Okay, so since this has a value of 0, that means that x minus 1 is a factor. So then what I can do is I can use my long division process. So if you go back and have a look at the last video, so I'm going to pop my divisor on the outside here, and I'm going to pop the thing that I'm dividing on the inside. So this was x cubed minus 3x squared minus 6x plus 8. Let's just double check that I've got those values all correct. Yep. Okay, so now what we're going to do is we're going to do the long division process. X fits into x cubed, x squared number of times. So that was our divide. Now we're going to multiply. X minus 1 times x squared makes x cubed minus x squared. Now we're going to do our subtraction. All right, so x cubed minus x cubed is just going to make 0, which is good. And then negative 3x squared minus negative x squared, so negative and a negative make a positive, so 3x squared plus x squared is going to make negative 2x squared. Okay, so we've done that, and we've done that. So let's start the cycle again now. X fits into negative 2x squared, negative 2x times. Then I'm going to multiply negative 2x by x minus 1, so that's going to give me negative 2x squared plus 2x, because a negative and a negative make a positive. Okay, and now we're going to subtract. So negative 2x squared minus negative 2x squared is going to be 0, which is good. That's what we want. Negative 6x minus 2x is going to give me negative, whoops, I should put that here, negative 8x. I'm getting ahead of myself. Okay, next we're going to do x fits into negative 8x, negative 8 times. So we've done our divide. Now we're going to do our multiply. Negative 8 times by x minus 1 is going to be negative 8x plus 8. Next, we're going to do our subtraction. And so that is just going to be 0. So that's good. We're left over with 0 because negative 8x minus negative 8x is 0 and 8 minus 8 is 0. So that's it. So this is going to end up as x minus 1, x squared minus 2x minus 8. And then if we can, we would then further factorize this function here. So we would look at the factors of negative 8 that would add to negative 2. And so for that one, it's going to be negative 4 and positive 2. So to finish factorizing, this is going to be x minus 1, x minus 4, and then x plus 2. And remember, originally that function was equal to 0. So now we can use our null factor law to say that x is equal to 1, 4, or negative 2. So that would be the entire process from start to finish. So what we're going to do now, we're going to practice some questions to use the factor remainder theorem. So let's have a go at this second question now. So I'm going to clear the page. All right, let's use our factor remainder theorem to find factors. So again, the first thing that we are going to do is we are going to list out factors of the constant. So for this case, our constant is negative 9. So we could have obviously a negative or a positive answer for this one. So this could be negative 1 or positive or negative 1, positive or negative 9. And then I could have positive or negative 3 as well. Okay, so let's test each of these. So if I do f of x divided by x minus a, and I have a remainder of 0, then that means that it is a factor. So to find that, using the factor remainder theorem, we're going to substitute in f of a. So for our first test, let's try doing our function here that we've got defined, divided by, let's just do x minus 1 again. So that means that I have to substitute f of 1 into the equation. So let's find that. So that's going to be 1 cubed plus 1 squared minus 9 lots of 1 minus 9. 1 cubed plus 1 squared is just going to make 2. 2 minus 9 is just going to be 2 minus 18. 2 minus 18 is going to be negative 16. Okay, so x minus 1 is not a factor. So not a factor. Let's try using another example now. So we tried using x minus 1. Let's try using x plus 1 to see if that makes a difference. Let's do it here. So that means we need to change this symbol in here as well. So I'm just going to pop negatives out the front here, and I'm going to pop some brackets around. Really important that we put the brackets around it, especially if we're putting this into our calculator, because Casio calculators operate in a very specific way. So like sometimes you'll put in a solution, or you put in type in an answer and you don't get what you think you're going to get. So the reason for that is you just have to put brackets around things. Okay, so negative 1 cubed is negative 1 plus 1, negative, and that's negative, and a negative is going to make plus 9, minus 9. Okay, so this is going to be equal to 0. So that means that x plus 1 is a factor. So then we would go through that whole long division process to determine what the other factors would be. Okay, so we could keep going with this now. We could keep testing different values in here to see which other factors there are, but I might do a new example and come back. Last one. Okay, so this was our original question. We're just going to demonstrate using the factor remainder theorem. So what we're going to do is we're going to look at the constants. So this is either going to be positive 1 or negative 1. So if we do f of x divided by x minus 1, and x minus 1 is a factor, then it will have a remainder of 0. So to find that out, I'm going to substitute in f of 1. So this is going to be 1 to the power of 4 minus 2 lots of 1 squared plus 1. So this is going to be 1 minus 2 plus 1. This is going to be equal to 0. That's nice. Okay, so that means that x minus 1 is a factor. Okay, so now what we could do, we could go ahead, we could do this whole long division process again to work out the quotient, but I'm just going to leave it as that because the whole purpose of this video is to show you how the factor remainder theorem works. If you do want to check out that long division video, I should already have it up on this Year 12 Specialist playlist. Alrighty guys, I will talk to you again soon. Have a wonderful day.